So then class, today we've got the exciting subject of looking at CO2, carbon dioxide. So that's uppercase C, O subscript for number 2. So we're going to look at the handling and management of that in an environment. You just couldn't make it up, could you? Good of you to wake up and join us as we review this Silent Ecowatt van from ENVIROVENT.
Well, that's all right. It was a bit of a revelation, actually. How many years did you spend as a teacher?
19 years teaching,
19
yes.
years. And for all these years, you just thought it was your teaching style that sent people to sleep. Yeah, is that right?
No, I didn't think that.
No, you did. Well, if you want to comment on Gary's teaching style, drop a comment below. But actually, as you did touch on there, we're looking at today the relationship between CO2, and that can have a dramatic effect on people in an environment if the concentration's too high. It can cause headaches, drowsiness, things like that. So that's really why people were dropping asleep in your lessons.
Yeah, and also at the moment it's a really hot topic, isn't it, about moving air in these currently difficult times as well.
Yeah, it is. That's a big topic. So it's also a great opportunity for electricians to get in, be seen to be advising their customers on some great options. And this inline fan is a good option. It is running at the moment, and it is super silent. Okay,
apart from my breathing you can probably hear, which will come in handy, I would think, at some point in order to get it to far into action, yes?
Yeah, so perhaps first let's have a little look at the setup that we've built here in front of us. Right, so let's have a quick tour of the setup that we've built here, Gary. Here's our Silent Ecowatt fan. So yes, it does look like a jet engine, but it doesn't sound like one.
And why is that?
Because there's a lot of attention being paid to reducing vibration, but also absorbing the sound that's created by the motor. Inside here is special acoustic installation, and that's that's one of the unique points of this. While we're here, okay, let's have a look at some electrical points here. This is obviously where we bring our cabling in there. We've got 2 wires coming in here. One's our main supply. This one here is the variable speed control, and that's a 0 to 10 volt signal, and that decides what speed the fan operates at. We'll come back to that in a little while. This is the 150mm version that at maximum power is 39 watts, IP44 rated, and suitable for air temperatures between -20 and +40 degrees.
Okay. So
that's the fan. Down to the controls. This box here is the receiver for our CO2 sensor, which again we'll come on to in a little while. So again, that has a main supply to it, and there's 0 to 10 volts signal that goes up to our fan. That talks to this clever piece of kit here, which is doing the CO2 sensing.
Okay.
And again, this has a main supply, but communication between this and the receiver here is an RF signal. So you have to pair these, and we'll have a look at how we do that in a while. So we've got a variable speed fan in front of us, but why would you want it to be variable? Okay, obviously there's recommendations for how often the air should change, and that is based upon occupancy.
Right.
So obviously you risk, designing for maximum occupancy, and you end up with a jet engine running at full power all the time, and obviously that causes energy efficiency issues as well. But it's best to vary that output depending on how many people are in the building.
Yeah.
And what else they're doing in the building.
Yeah, I can say they could come in and out. It might be a sports hall. You might have 100 people in there and then 3 people doing yoga another time.
Yeah.
So we can increase the speed by obviously altering the CO2 in here. Are we going to do that now? Shall we have a breathe on it?
Now normally, electricians, you probably might have fitted a humidity sensor for obviously humidity, steam from showers and things like that. So you might not be too familiar with a CO2 sensor, but this is the sensor itself. It's got this green LED at the bottom.
Right.
So at the moment it's operating at a low level. So this is at about 10 watts. So we're moving 67 litres of air per second.
Okay, that makes sense.
Yeah, but it is, again, super silent.
And the silence will be improved, won't it, by actually having the actual ducting on it as well. So yeah, that will actually limit the sound as well.
Yeah, and obviously ducting has a huge performance, and if you're designing a system, we recommend you get in touch with ENVIROVENT. They're there to help you with that system design. But let's have a crack at this, Gary. So you go
first time ever my breathing's come in handy for all those people who've noted that in the past.
Deep breath, officer.
It's green at the minute.
Yes, that's a low setting.
I take it for the rest of the shot I'm going to be doing this, am I? Yep.
Yeah, should be fun.
Yeah, for one of us.
You're not playing the harmonica, Gary.
Yeah. Sorry, officer. Oh, amber.
Yeah, so it's got a amber.
Okay,
And
so
obviously there is a time lag. This doesn't sense in real time. At some point, the fan will sort of step up to a higher level. You might as well keep going to.
Oh, got it to red.
Oh, yeah, there you go. We can stop now. Which is a little.
Okay, so this will pick up.
Yeah,
Right, it's already picked up.
Yeah.
But from previous experience, that sounds like it's properly going for it. It's actually, there's another level up from this, isn't it?
Yeah, it's not at full power yet.
No.
It's just started.
It's holding things down. So it sensed CO2 in the area. It was already, obviously the fan was already working. We saw it look effectively like a trickle. Yeah, okay, we've got it to amber, and then we've got it now onto red.
Yeah.
And that is...
I'd suggest that is now at the full setting. Do
we
the
go,
old
so-
instruction manual test. Yeah.
Look at that. Wow. I can hold a copy of the regs, I would imagine, on the side there.
I'll take that off before it sucks it through the fan.
All the way through. So, of course, we've touched on it again. We said about the noise being generated here. The actual ducting itself will help reduce that noise. This is an incredibly silent or quiet fan, isn't it?
Yeah, we're shifting 151 litres of air per second. And as I say, when you read up on this, obviously there are recommendations for how often air should be changed.
Yeah.
And in these current times, those are quite fluid, which again, why a variable system is pretty useful, because obviously regulations and recommendations can change. Therefore, with this system, you're covered, and obviously this you can set it up to match those requirements.
We also like to give electricians opportunities, and we think this is an opportunity, not just in this current times, but obviously we talked about schools and things like that, and managing CO2. Shall we have a little look of how we went about actually making some of these connections and fine-tuning?
Yeah, have a look at the wiring. Yeah, let's dive in.
So let's go through some of the assembly processes. I'm going to need to get out the inline fan, so I'm going to release these straps on either end to do so.
Okay, look a little bit like cable ties.
Yeah, they are. So that just wiggles out, and it allows you to fix it down. We're going to use this wooden board. There's 4 fixing screws to do so. So I'll screw that into position before returning the inline fan. Yeah, pop that in like so.
Okay, so the bracket itself, interesting, also functions as the coupling to the ductwork system as well. That's clever design.
They also help reduce vibration, say where it's mounted in a false ceiling. You don't have to have it in any position in particular, so that arrow is obviously the direction of the airflow. That doesn't have to be top dead centre, it just depends on your circular wiring loom where you want that positioned.
Good, yeah.
So
this is the connection for the variable speed control. So this is a 0 to 10 volt signal. Again, just putting some ferrule terminations on there. And again, it goes in the relevant terminals on the control side.
So between 0 and 10 volts, that's controlling the speed, is it, Gordon?
Yes, that's it. Yep.
So we'll get that one screwed into position. It's going to need a supply as well in here, as well as the control wire.
So there's that. So yeah, there's.
Bring that one in, yeah. Final connection. It's got a handy little cord grip there, I notice as well. It just sort of loops in and round.
Yeah, it is. Yeah, and again, that top you can position that in any location depending on where your cable's coming from.
Yeah, so it helps, doesn't it? So you can have it whichever way around you want, circular, so that's good.
Yeah, a little rubber gasket in there to get that IP sealing. So this is our control module, just wiring the 1 to 10 volt signal in there.
So with the wiring complete, I take it we're into pairing mode now.
Yes, we've got to pair our CO2 sensor with the receiver module. So when you switch on the receiver, it goes into a search mode to find the sensor. So now the sensor, we push that button there, and we're now looking for this flashing light to go permanent green. That shows it they've linked together.
Okay, that was simple. That's already gone green.
Simple
So what's next?
Well, you can confirm that that's definitely the case by just pushing this button again here on the sensor, and we'll just get a little flash of the red LED there 5 times. That means it's linked up. You can pair up to 4 sensors with each receiver, so you might have it in different parts of the room.
Right, okay, got bright light now.
Okay, so this is the this light indicates the level of CO2, so amber, mid-range, green, low end. But that in a dark environment, that might be a little bit distracting. You might want to turn that down, Gary, and you can do that on that little potentiometer.
That's pretty clever, isn't it? So we're into these dip switches. What's going on here?
Yeah, so this sets the mode of operation for the fan. So obviously that's important depending on how you want the fan to operate. Again, yeah, comprehensive instructions there. And then next to that, we've got this the sensitivity of the CO2 sensor. So obviously that's the amount of carbon dioxide in the air, and obviously the required fan setting for that.
Okay, so again, consult the instructions for that. Wow.
Little detail there, look at that little metal clip.
Okay, yeah.
Remember when you have possibly your tyres changed on your car?
Okay, and that's to balance the fan out, is it?
Balance the fan, get a super silent operation.
So every stage there of the assembly and setting up the actual pairing was simple, wasn't it?
Yeah, nice simple system.
So what sizes they come in and what's the warranty?
Okay, we've got a 150mm version here, but you can also get 100 and 200mm versions, all with a 5-year warranty. Obviously this is a variable speed fan. If you wanted to use a conventional fan and just switch it on and off, but still use the CO2 sensor receiver, this will switch up to 3 amps of conventional load.
All right.
Now, if this isn't your thing, do check out the video also made on the ENVIROVENT Silent Dual 100, which is more for those domestic settings. Obviously, you can use this in domestic settings as well, but the Silent Dual as well, that had some fantastic features in as well that, yeah, again, make for high quality installation. I will also put a link in the description below for some more information about ventilation of buildings. Obviously, as we said, this is a fluid situation and changing all the time.
Yeah, and as always, we're interested in your comments. Have you fitted any other products by ENVIROVENT that you want to tell us about, that you found were fantastic and help the community out? Have you fitted one of these Silent Ecowatts in the past? Are you thinking about fitting them in the future? We'd love to hear your comments and we'll try and get back to as many as we can.